My name is Jongyoon. People call me Jay, and I'm an associate professor at MIT in the Department of Electrical Engineering and also in biological engineering. What I do in my lab is simply explained as a manipulation of molecules and ions. Molecules and ions are the languages of biology and chemistry, so you want to either understand what's going on or at the same time manipulate what's going on. To do that, you need to have a tools to manipulate these molecules. I use the tools that is coming originally from electrical engineering and sometimes from physics. So my original educational background is in physics and engineering, but I'm applying those knowledges and skills and tools to solve some problems in biology. The way I use is nanofluidic structures, essentially a small scale structure with a nanometer or tens of nanometer size, and I use them as a filter. Many people use the filtration for all kinds of things. Biomolecule separation is largely a filtration process. Desalination is a filtration process. Fuel cell batteries, you have a membrane in the middle which filters out certain kinds of ion over other kinds of ion. So it's such a fundamental engineering device, but the scientific understanding of that filtration process is not there. I don't think we know enough about the exact details of what happens. From the purely scientific point of view, I think that's the most important problem to be solved. My sense on different people's perspective on the same problem is that there is no right way or wrong way of looking at the problem. It's just a different language. That actually reflects the way that I approach the problem, whether the problem is from biology, whether the problem is in energy, or other problems. What I benefited a lot is actually just casual interaction with people. I can bounce my ideas on them, and usually I get a very valuable feedback. And that kind of challenging feedback from other completely different perspective actually is very helpful. The graduate student as well as postdoc is such an essential part of my research activity. In the real sense, they are the one who actually go in and do the research. For undergraduate students, what I try to do is project my enthusiasm on the subject that I'm teaching. Now I'm trying to use as many examples as possible so that I can at least deliver that this piece of equation that students need to master is actually a very cool thing, because of that equation you can do this interesting research and engineering. RLE is the laboratory structure that really enables all the research component of my lab. And the support that I got from RLE as a laboratory was exceptional, I have to say. All the MIT departments and even buildings are integrated with each other. They are not separate. People from bio department can easily walk up to mechanical engineers and electrical engineers to talk to them and interact with them. And that intellectual feedback process is very crucial to the success of MIT, in my opinion. Success in the research really means that you create a knowledge or device or concept that hasn't been known to others before. What drives me every day is this thinking that at the end of this work, I could be generating a knowledge, a piece of knowledge, however small or big that might be, that hasn't been there before in the history of mankind. That idea, that thinking, that prospect is very exciting and great.